Okay, so today instead of moving on to our next section, I'd like to make sure we have this one. I think it was a fairly easy section to comprehend. However, I'm a math teacher, so of course I comprehended a little better. But I just want to make sure that we have it down and we can move forward. So let's start with yesterday's homework, which is actually due today, meaning you're going to make basically get some easy points if you watch the video. So the first thing I'm going to do is I'm going to go over the homework assignment, starting with number 1. Identify the degree of each monomial. So remember, if we have variables, all we have to do is take the degree of the variable. If it's a single variable, in this case it's x to the second, that tells us that this is a degree of 2. In question 2, we have two different variables with two different exponents. So p to the third and m to the fourth. If I do 3 plus 4, that gives me my degree, which is 7. And number 3, I have x to the 8th and y to the third. Just combine those two. 8 plus 3 gives me a degree of 11. And that's all you had to do for the first 3. Moving on to number 4, rewrite each polynomial in standard form. Then identify the leading coefficient, degree, and number of terms. Lastly, name the polynomial. So the first thing I'm going to do is put this in standard form, which means that my degrees are going to go from the highest to the lowest, which means I need the highest exponent to come first. So that's going to be negative 4x to the third plus x squared plus 7x plus 6. So I went from my highest to the lowest exponent. This would be x to the 0. That's how you know it's the lowest, because there is no x with it. Identify the leading coefficient. Leading coefficient, once it's in standard form, is the first number in front of the highest term. So this would be negative 4. The degree, it's x to the third power. So my degree is 3. Number of terms, this would have 4 terms to it. 1, 2, 3, 4. So it's going to have 4 terms. And now we have to name this polynomial. So when we're looking at naming it, we have to look back at our chart. First, it is going to be a cubic, because my highest exponent is 3, and it has a degree of 3. So it is going to be a cubic. And then if you remember, 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and then we didn't have a name for anything above 3 terms or a trinomial, so we just stick with polynomial. So this is a cubic polynomial. Number 5, first I have to put it in order from the highest exponent to the lowest. So 2x to the 5th plus 7x to the 4th. There's no x to the 3rd, so this becomes just plus x squared minus 12x minus 3. My leading coefficient is the one that comes first. That's a 2. My degree is the highest exponent, which is 5. There are 1, 2, 3, 4, 5 terms. And because it's more than 3 terms, we know it's going to be just a polynomial. And then it's a degree of 5, which makes it a quintic polynomial. All right, on to the next ones. And in this group, I'm actually going to create a little bit of space here. Because I want to put them in standard form first, and then I'll align them vertically. So let's put them in standard form first. I have 2x squared minus 2x plus 6. If I look at this, it's already also in standard form. No, it's not. The 5x is out of place. But I have 11x to the third minus x squared plus 5x minus 2. Now you'll notice I only have I only have one thing that's to the third power, so that one stays as 11x to the third. 2x squared minus x squared, those are the like terms there because they have the same variable with the same exponent. They're both x to the second power. 2 minus 1 gives me 1, so this is just plus x squared. Negative 2x plus 5x is 3x, and positive 6 minus 2 is 4. Now, because I chose to write it in standard form from the beginning, it's already in standard form once I hit the end. The other way I could do this would be to just start looking at it right away. 2x squared, look for an x squared over here. 2x squared minus x squared gives me x squared. Once I've tackled that, I cross those out. Negative 2x plus 5x gives me 3x. Once I've tackled that, I cross those out. 6 minus 2 is 4. Tackled that, so I can cross those out. All I'm left with is a plus 11x to the third. And now I would just need to put this in standard form. It would be 11x to the third plus x squared plus 3x plus 4. So it ends up as the same thing as it should. Number 8. Let's do the first one in standard form. 5x to the fourth and x squared. I'm going to leave an even bigger gap because I'm missing an x to the third in there. Move on to the second part of this and put it in standard form. I have minus 2x to the fourth first plus x to the third plus 9x squared plus 7. You see how leaving the gap really helps me? Because I can look at this now, 5x to the fourth minus 2x to the fourth, that's just 3x to the fourth. There's nothing that goes with x to the third. And so this stays lined up. X squared plus 9x squared gives me 10x squared, and then plus 7. Because I wrote them each in standard form to start with, and now my answer is going to be in standard form. I can always check it to see. 4, 3, 2, there is no 1, and then there's no variable, so I know I'm done. Jump to 7 and 9 now. Number 7, I'm going to do 12x squared plus x. When I look at the back side, I see I have an x to the 7th. So I'm going to move this over. X to the 7th is going to go out front. I'm sorry, that was number 9. Guess I should do 7 first, huh? X squared minus 8. And if I look at this one, it's minus 3x to the 3rd. Remember, I have to distribute that negative to each term. Then what would come next is the 9x squared. Make it negative, so it would be minus 9x squared plus 6x and plus 4. Negative 3x to the 3rd stays. X squared minus 9x squared is negative 8x squared. Nothing to go with the 6x. Negative 8 plus 4 is negative 4. So it's negative 3x to the 3rd minus 8x squared plus 6x minus 4. Now let's do number 9. I have 12x squared plus x. If I start looking at them, I have x to the 7th is going to go way out in front. The next one is an x squared, so I know it'll line up under this. It's minus a negative, that makes it plus 9x squared minus a negative 8x, so that's plus 8x, and then minus 6. X to the 7th is just x to the 7th. 12x squared plus 9x squared is 21x squared. X plus 8x is 9x. And then minus 6. Number 10, graph each polynomial function on a calculator. Describe the graph and identify the number of real zeros. So if I graph this on the calculator or on Desmos, that would be the easiest. So once we're in Desmos, we can graph this. It's x to the 3rd plus 2x squared minus 3. And our question asks us the number of real zeros. In order to find our zeros, we can simply say it's here where it crosses the x-axis. It only does it one time, so that would be at 1, 0. If you want to describe the graph further, you could say the y-intercept is at 0, negative 3, and that it has a vertex at negative 1.33, negative 1.815. Number 11, x to the 4th minus 5x squared plus 1. When I look at this one, I need to look at how many zeros it has. And Desmos provides that for us, basically. Tells us that there's one there, 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 and there. So if you would just provide your graph for this, that would be perfectly acceptable as an answer. And you could even write on there, it forms a W. All right, last question. The height h in feet of a baseball after being struck by a bat can be approximated by the function h of t equals negative 16t squared plus 100t plus 5, where t is measured in seconds. Evaluate h of t for t equals 3 and t equals 5. So if I plug those numbers in, it's going to find us the height of the ball at 3 and 5 seconds. So h of 3 equals negative 16 times 3 squared plus 100 times 3 plus 5. 3 squared is 9. Negative 16 times 9. I can't say I know what that is. That's negative 144. Plus 300 plus 5. 305 minus 144 gives me 161. So the height of the ball at 3 seconds is 161. That's what all you would have to say here. Describe what the values of the function for part A represent. It's the height of the ball at these times. At 5 seconds, same thing. I'm just plugging in 5. That's going to give me negative 16 times 25 plus 500, because that's 5 times 100. So negative 16 times 25 is negative 400, and that's plus 500, which is 100, plus 5, this would be 105. So 5 seconds, the ball was at 105 feet. At 3, it was at 161. That tells me at 5 seconds, it's already on its way back down. Now, one question that people might ask is where this plus 5 comes from. That would be where the ball hits the bat at. Not that that was one of the questions that was asked, but people often ask where these numbers come from, and that's where that one would come from. All right, well, that's your homework assignment completed, and everybody should get a perfect on this, obviously. If you watch the video, send me the word quintic, since it's similar to my first name, and I'll give you 5 bonus points. All right, guys, have a good night.